All right, let's try take two now that my mic is audible and my camera is not covering the console. So if you are looking at code, either yours or somebody else's, and you see blah, 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 and set of parentheses, notice that this looks like gibberish, but PyCharm isn't underlining it. There's no red. There's no complaint here. Python knows what this is, and I know what this is, and you should know what this is. This is a function call, and you can tell that because of this set of parentheses here. And that is how Python knows that this is a function call, is this set of parentheses that are attached to something by some name. Okay, so anytime you see a pair of parentheses that's attached to something, if it's not math, this is a function call. So let's talk about user-defined functions. So I'm attempting to call a function by this name, and it takes no arguments. Now Python's going to complain when I try to run this. It says, hey, that name is not defined. I don't know what this is. Fair enough. Since this text is in white in PyCharm, this is not one of Python's functions. We have to define this function ourselves. So let's define a function by that name. And it takes no arguments. And then there's a colon. And then let's just have it, let's call the print function, since there's a set of parentheses there. And the print function does take arguments. It takes string arguments. So let's just have it print the function name. Okay, there it is. So Python is going to read this file from top to bottom. It's going to ignore anything that's commented out and in gray because of these hashes. It's going to read from top to bottom, and it's going to say, oh, look, he's defined a function by this name. It takes no arguments, and then that's what it does. I'll remember that for later. And then when it gets down here, this is the function call. It's actually going to instruct this to run. Okay, so let's add something here. Let's again call the print function, and let's give it an argument, and let's just say done. So now it's going to print the name of that function, and then it's going to print done. Okay, so that is how you can do a user-defined function, right? So let's move that here. That's a user-defined function, and here it's going to be in white. And when you define it, it's going to be in blue. Right? Let's talk about some other functions that you guys have maybe seen already, or are very common if you're going to start looking at code, or you've been coding for a little while. Some of the functions you may have already seen. How about input? That's a function. Okay, you can tell it's a function because it has parentheses attached to something. Now the text here is in blue, just like it is here, because this is a Python global function. This is a known special word in the Python language, and so the IDE is going to write this in blue. Now input is a function that has an optional argument. So you may have seen it like this. You may have seen input called with no arguments, or you may have seen input called with some string that's like a list of, or some instructions, telling the user what to do when you go to type stuff in, right? So if I run this, it's now going to print that function name. It's going to print done. So let's skip those for now. Let's just skip those, and then let's do this. So if I run this, it looks like my console is empty. What it's actually doing right now is it's waiting here for me to type something in. And the input function has printed the instructions to the console, but the instructions we gave it were blank. So it printed a blank. So it's waiting on me to just type something in here. And now that line finishes, and now it comes here. And now this input function call, we gave it an argument of instructions. And you can see that's what it printed to the console, and now it's waiting on me to type in something else. Okay. Now this isn't very useful, partially because these functions, the input function returns a string value, and we're not doing anything with that string, so Python's going to throw it away. So if we want to do something with that string value, how about we store it somewhere? Let's store it in a variable called string variable. Okay, and now, rather than print instructions, let's see if we can pass that string variable as an argument to the input function, because we just saw the input function can take a string argument. So let's give it a string argument of whatever I type in the first time. Okay, so let's run that. So I'm going to type in, and now that's what it prints, and asks me to type in something else. Okay. So when you see syntax like this, you see a variable name. You can see here it's in white because this is a user-defined thing. I have defined this. Just like here, Python coded this, or PyCharm coded this in white because this is a user-defined thing. I have made this. This does not exist in the Python language. Same here. This doesn't exist in the Python language, so it's coded in white. So I have a variable, and I'm declaring it here because this is the first time we've seen it. I'm declaring this variable, and then I'm assigning it a value equal to the return from this function. So let's go back to our user-defined function up here. If you define a function in Python like this, you do a def, you name it, you put in any arguments it might have, then you do stuff. If you do not put a return in here, or if you comment it out, if it's just not there, when Python gets to the end of this function, when it runs out of stuff to do, it's just going to return anyway. It's going to automatically go back. So whenever this function call here got run in that code, whenever that function was done, when it returned, Python basically reads from top to bottom. So it's reading. It hits this function call and it says, oh, I need to go to here. And it does this stuff. And then it returns the cursor back to here so that it can keep reading. One of the ways you can make functions more useful, you can use this return keyword to exit a function early if you hit some condition, because return stops the function from running. Wherever it's at, whatever it's done, it'll exit the function. And you guys have used that before. But return kind of has a double meaning. It doesn't just return the cursor basically to where it was reading. You can also return a variable here. And then whenever I call this function, just like when I call input here, input actually has a return value. This function has a return value. It returns a string variable, which is whatever I type into the console. And so I can store that return value in this variable. So similarly here, for if I define this function and I give it a return value, like let's just say this returns a literal value instead of a variable. I can some new variable. I can make a variable and I can assign it a value equal to whatever that function returns when it is done. And now rather than print done, let's just print that variable. All right, let's comment this stuff out. Now it's going to print the name of that function, which it doesn't here. We return this literal here, and then that gets stored in that variable, and then that's what we print. So we print 5, right? But this isn't very useful. So why don't we change this a little bit? Why don't let's change this function name to, let's first introduce the argument, or the idea of arguments, function arguments. Okay. So we're going to move this up a little bit. Okay. And we've already done this. Okay, so we've covered the fact that you can return something from a function. You don't have to. If you don't have a return statement at all, or you just have a return with nothing behind it, Python will return basically an empty or a null value. Okay, but you can return stuff. You can actually return multiple things here, you know. But let's talk about arguments, because returns and arguments are both ways that you can make functions more practical, more useful. Because a function that just prints something and then is done, well, why define that function and then call it, and then, you know, if I could just replace that function definition and that function call with the print statement. Let's make the function do something more useful. So why don't I call this sum two numbers? And now let's go over function arguments. So when you declare a function, when you define a function like we do here, we make a new function. We can require that this function be given some number of values in order to be called, some requirement. So and we can name these variables, these values, whatever we want. So let's call the first argument a number, and then let's put a comma so that we know we have another argument. Let's say another number. Okay. Now instead of printing this gobbledygook, why don't we make a variable called sum? We're going to set that variable equal to our first argument plus our second argument. Whatever has been passed in, we're going to add those two numbers together. We're going to store it in that variable. And then, rather than print this sum here, let's actually send that sum back to whoever called this function. So since we've changed this function name, let's change it down here when we actually call this function. But now this is going to complain, all right? Python's going to complain here. Do you know why? Let's run it and see. So it says, hey, there's a type error. This sum two numbers function is missing two required arguments. So when I do this line, when I do this function call, there is no function by this name that takes no arguments. There's a function by this name that takes two arguments, but not one that takes none. So I have to actually give this two values. So why don't I do 1 and 5. And now PyCharm's actually going to give me a little ghost reminder here of like which one of these is which. This didn't actually get inserted. There's no actual text here. It's just the 1 and the 5. But now if I run this function will add these two numbers together and then send that value back. And then we are storing that value in this variable and then printing it. So this should print 6. And so it does. So that again, as a function, is not super helpful. It's convenient because, you know, I can do this. I can copy this block of code here, and rather than sum 1 and 5, now I can sum like 3 and 7. And now it'll print both of those, right? And I'm using the same variable name here. We're declaring it here since this is the first time we've seen it, but we're overriding it here because it already exists, and we're just assigning it a new value. And the new value we're assigning it is the return from the same function, but given different parameters. That return value, which is there, is going into that variable. So this is a little more useful when we have functions that take arguments or have returns. Those can both help make functions more useful. We can make them even more useful by doing something like this. So how about the first time we call this function? Right now we're using two arguments that are both literals. They're given fixed values here. But let's say I have like some variable and it's a number with a value of 8. So I can provide that as either the first or the second argument to that function call, right? And that, it doesn't matter because both of these are supposed to be numbers. So now this will print 8 plus 5 and then 8 plus 3. And there it does. So that is you can call functions with literal values as arguments or with variable values as arguments. Now, since we can do that, what we can do is we can actually, the first time we call this function, let's just put the print statement back. The first time we call this function, we're going to get 13. This is 8 plus that 5, and we store that in there. Why don't we use this variable as the second argument the next time we call that function? We're going to call that function again, but this time we're going to use the value we got back from calling the function the first time to call it a second time. And then we're going to override that value like we did before, and then we're going to print the new value. So now, the first time we print 13, so now we should print 13 plus 3. And there it goes. So that is a good way you can make functions more powerful, is you can have a return value, and this doesn't have to be a number. You could return a string, you can return a list, you can actually return multiple different values. Maybe I wanted to send back the sum, the difference, the quotient all together. I can do a bunch of different things with this function to make this more useful. But the point is, I can call it multiple different times and just change the arguments and get a different outcome. And that's why functions are really useful. So, we've talked about returns, we've talked about arguments. Let's talk about, we talked about some of Python's special functions that you've probably seen before, or if you're just starting coding, you'll see these very often. The input function is a Python special function. You see the text here is in blue. My function, its name, when I call it, is in white. But when I call this function, that PyCharm is going to write this in blue, because this is one of Python's special functions. Okay. Other Python special functions include, that you've seen that are very common, are print. You may have seen integer. You may have seen string. You may have seen float. These are all Python special functions. And each one of them works a little different. Like we've saw how input can optionally take a string argument as instructions that it'll print to the console. The print function, you can run the print function with no arguments, right? And unless you tell Python otherwise, the print function will print the entire list of however many arguments you give it, and then it will print a new line character with that little /n, and that will basically push it down to the next line. So if you call print and you don't give it any arguments, it will still print that empty list of strings and then a new line character. So you'll basically just put in an empty line into your file console, wherever you're printing this to. Okay? Some of the other special functions you've seen is the integer function. This takes one argument, and usually it's like a string that you got from the console, and you want to cast that string or that float or that other data type and try to force it to be an integer. And so the int function, you know it's a function because it has the parentheses here, it takes one argument and it returns, the int function actually returns an integer value. So we want to store that integer value somewhere. Okay. And this is probably complaining because I gave it a literal. Okay, no, it's fine. Okay, so this function will return an integer, and so I'm going to store that in there, right? Likewise, this function returns a string, so I would need to store that somewhere. This function returns a float, so I would need to store that somewhere, right? These functions don't just do stuff. They take arguments. They take arguments, sometimes multiple arguments, and they return a value that you need to do something with. Okay. So let's check those. Now, some other functions that you guys have seen this semester. You may have seen some named function, and you know it's a function because it has parentheses. And maybe it has arguments in here, maybe it doesn't. But you can see the append function, which you guys used for the list assignment, the append function is not being coded blue. That is because these are Python special global functions. Append is not a global function. It is a specific function of lists in Python. And so because this function does not exist in my file, I have not defined this function, and Python hasn't defined this function, I need to tell Python where this function is, or it'll complain. All right, so if I run this now, it's going to print those two numbers, and then it's going to complain, hey, the name append is not defined. I don't know what this is, or I don't know where this is. Okay. So in order for Python to find this function, you have to give it some context. You have to tell it where that function is. And the way you tell Python where a function is, if you haven't defined it in this file, is to use a dot. Okay? And then whatever you put to the left of the dot tells Python where that function is from. So you may have seen list.append, or whatever the list variable is, .append. And then when Python goes, oh, I know this is a list variable type, I will look in list for the append function. And then append takes an argument. So maybe for your assignment, you had to give it like an item, a new item to append to that list. So this list is going to run a function, and that function is named append, and the argument that you gave the append function was either a string literal here, or maybe like some string variable. Right? That's how that looks. Now, the other place you have seen this kind of notation here is, if you remember, there's a random function you guys have used for a couple assignments. And again, in PyCharm, this isn't being underlined. Python knows this is a function because there's parentheses here. But if I go to run this, let's get rid of this line. If I run this, Python's going to complain, hey, random's not defined. Hey, it actually gives me a nice reminder. Did you forget to import random? So, another place that functions can live outside of your file here where you have defined them, or outside of the Python language itself, the global context for Python, another place that special functions can live are in libraries. And you guys have used libraries already. So when you see import and then a word at the top of a Python file, this is a library. And a library can contain, among other things, functions. Now let's disambiguate this a little bit. Let's give this library an alias. Let's name it something different, because this will look really weird otherwise. So I'm gonna, while I'm in this file, I'm gonna refer to this random library as random library rather than random. So I can now call this library by this name instead. So now I want to call the random function from that library. And now it's not going to complain. Okay? And if I hover over this in PyCharm, it's actually going to show me, hey, look, random is a function that takes a float, and it returns a float value from 0 to 1. So there's a little reminder here. But anytime you see a pair of parentheses attached to something, and it's not like doing math, that is a function call. Or a function declaration, like up here. This is a function. And whatever is in those parentheses, even if it's empty, those are the arguments that the function requires in order to run. And then if there's a period before the name of the function, that period is telling you where that function is coming from. It can either come from a library or from like the like Python global context, or you can think of them as like global Python libraries that it doesn't automatically import for like specific functions from lists or from sets or for other things. Now, that seems like an aside or a random callback, but that is important. Knowing that stuff is important when we go to talk about the difference between these two kind of loops and what some people missed on the exam. So, you guys have learned about two different kinds of loops. You've learned about for loops and while loops. Now, they are both fairly similar in that you have what's called a loop condition. And that is something that is a expression that has to evaluate to either true or false. So let's look at one. So if I do for, and then a variable name, in range, and this is why we did functions first, range is a function that takes either one or two arguments. Range needs to know where to start and where to stop. So if you give it two arguments, like 0 and 10, then it knows 0 is the number I start at, 10 is the number I stop at. You may have seen the range function called with only one argument. The first argument, the starting position, the starting argument for range is optional. If you do not provide it one, it will assume it will use the default starting value of 0. So, this line, and let me comment this one out. This line do the exact same thing. If you call range with one argument, the first argument is assumed to be 0. It doesn't have to be. You can call range with two arguments and start it at -5 or at 8, but you can also manually start it at 0 by giving it two arguments, right? So let's have this this for loop do something here. I want to print this iterator value. So let's call the print function, and let's give the print function an argument of that variable. And this is going to run 10 times. Let's run it 5 times. Let's run it in range 0 to 5. Let's see what this does. Look, it prints the number 0, 1, 2, 3, 4. So, when you declare a for loop, whatever this variable is that follows it, you may have seen it as I, you may have seen for I, you may have seen it as X, you may have seen it as, for something else, right? But whatever it's called, this is the iterator variable that is being declared right here in this line when you make this for loop. This variable is made, and if you hover over this in PyCharm, it will actually show you, hey, this has to be an integer, so we're going to assume that it is one. And when you make a for loop, the iterator is given a default starting value of 0. So, loops determine whether or not to run based on the loop condition. So this word here in orange, this is the kind of loop. So if we did a while loop, you would see while is also put in orange. Okay? So that tells it what kind of loop and also that it is a loop. Everything that follows that before the colon, that is the loop condition. That condition has to be an expression that evaluates to either true or false. It can't be a number, it can't be a string, it has to be either true or false. If, when Python is going from the top of your program to the bottom and it hits that loop line, it's going to check the loop condition. And if the loop condition is true, it's going to run the stuff in the loop. When the loop is done, when the loop reaches the bottom of all the indented stuff that belongs to it, the loop is going to loop back, it's going to come back to the start, and it's going to check that loop condition again. And if that loop condition is still true, it's going to run the stuff again. And if it's false, it will then skip the rest of that stuff. Now, this is one major difference, the mechanical difference between for loops and while loops. The mechanical difference is that for loops have a built-in iterator, and that iterator is automatically ticked up by Python whenever this loop restarts. So if I run this, you can see the only thing we're printing out is this variable. You don't see, and these are comments, right? I'm not doing anything here. Python is automatically ticking this variable up every time this loop restarts. It's ticking it up by 1. And that variable is also the thing that determines whether or not this loop condition is going to be true or false. This variable starts at 0, and Python automatically ticks it up by 1 whenever this loop restarts. So the first time we print 0, and then when the loop restarts, it gets ticked up to 1. And so we print 1. Then it ticks up to 2, 3, 4. And then the last time when it ticks up, it says, hey, is 5 in the range between 0 and 5? And range doesn't consider the second argument to be inclusive. So 5 is equal to 5, so it's not within 0 to 5. Okay? So 5, when this variable becomes 5, 5 is not, the question is 5 in the range 0 to 5. And when that's false. So then this skips, and then the program exits because we're done. For loops, automatically, when you declare a for loop, like we've done here, when you make this loop, this variable is created. Whatever you name it, it doesn't matter. This variable, this iterator, is automatically created, and whenever a for loop restarts, this iterator is automatically ticked up for you by Python. You do not have to, like, come in here and add one to this. You don't need to do that. And in fact, doing that won't do anything, and we'll see that a little later. So now let's look at while loops, because they're a little different. So if I write while, and let's say while, let's make a, you know what, let's just use this one for now. Actually, let's not. Let's make a new one. Let's say new iterator, and let's give it a default value of 0. Okay. As long as, or while, this variable is less than 5, colon. We're going to do some stuff. And we'll just, you know what, so that it doesn't complain, why don't we just print that value? Let's print that number. As long as that number is less than 5, let's print that number. Now, there's 2 things wrong with this. Do you see them? Let's run it. This should print 0 to 5. In fact, let's just comment this out for now. Let's comment this out. Let's just do the while loop. Well, there's a couple problems with that. There's 2 problems. First is this is just printing out 0. The second is, you can see here by this thing scrolling, this is just going to run forever. So, why is that? While loops, similar to for loops, you have the orange text that tells you this is a loop and what kind. Then everything that follows that before the colon is the loop condition. And that condition evaluates to either true or false. And whenever the loop restarts, it will check that condition again. If that condition is true, it will run the loop again. So the only thing this loop does is it prints this value, kind of like we did up here. So why does this loop run forever and this one didn't? And why did this one just print 0 when this one printed 1 through 5? Like I mentioned before, for loops, their iterator is automatically ticked up by Python itself when the loop restarts. While loops do not do that. So that means this value never gets changed. And so this condition is always true because it's always going to be 0. So this will keep running forever. And it's also not helpful because it's only printing out zeros forever. So if we use a while loop, we have to manually update this iterator ourselves before the loop restarts. And now this prints 0 to 5, and then it stops. Because when we update this value, we keep adding 1 to this every time this loop restarts. Eventually, when this value hits 5, the question, is 5 strictly less than 5, becomes false. And so then this condition becomes false, and this loop skips, and we exit the application, goes, we're done. Now, if I comment this line out, it's going to complain. So it does. It says, hey, this name, new iterator, is not defined. In a for loop, when you declare a for loop, the iterator, whatever you call it, maybe you just call it like lowercase I or lowercase x, whatever it's called, it doesn't matter, right? This variable is defined and created right here when you make this for loop. While loops do not do that. If you're going to use a variable in your loop condition for your while loop, you have to declare it before you use it, just like you would anywhere else in Python. Okay? So, a lot of people lost points on, I think it was number 18. So, here we go. We've talked about the iterator variable. Both of these loops are useful. One has a few more stipulations, but it is more flexible. So, you saw on question 18 of the exam that you can use a while loop or a for loop, and we've shown that here, to do exactly the same thing. That for loop prints the numbers from 0 to 5, and then the while loop prints the numbers from 0 to 5. You can use either loop to do anything if you're clever enough about it, and you remember the requirements to run either kind of loop. A lot of people lost points on 18 when you're converting a while loop to a for loop, or some of you had the opposite question where you're converting a for loop to a while loop. Let's separate these a little bit. If you had this for loop and you wanted to convert what this for loop does, you said this was the for loop you were given, you need to convert it to a while loop. If you did not manually declare the iterator variable before you went into the while loop, then the while loop will throw the error, as we saw earlier, when that's not defined. So you had to manually add whatever the iterator value was called in the for loop. You had to manually declare that variable, then use it, and you have to manually tick it up inside of the while loop. Because if you don't, not only will it not print what we want it to, it'll also run forever, which is not good. So if you didn't do both of those two things when you converted a for loop to a while loop, you lost some points. Because you need to do this, or this just won't do what it's supposed to do. Going the other way, if you were given this while loop and you needed to convert it to a for loop, if you left in the manual declaration of the iterator or the manual tick up of the iterator, you probably lost points. Because the for loop does both of those things for you. And if you do them manually, sometimes Python will get messed up depending on a lot of complicated under the hood things. But what you need to know is, like, the for loop will handle the declaration of the iterator and the incrementing of the iterator. It does it for you. The while loop does not. So the difference between these two kinds of loops isn't what they can do, it's how they do it. For loops are really, really good if you have a specific... Yep, so here we go. We've talked about converting from one to another. Now let's talk about the sort of practical differences. When to use one kind of loop or another. If you can use either loop to solve either problem, then which one do you pick? Or, like, why do you care? Realistically, it doesn't matter. If you're clever enough or you know how to write the code, you can use either loop, and realistically it doesn't matter. If you're struggling to choose a good shortcut, a good thing to sort of prompt you, is because a for loop has an iterator and it ticks it up for you. For loops are really good at counting things. They're really good at running a fixed known number of times. So here we knew this was going to run exactly 5 times. So like in your Wordle lab, when you know after you get a valid input, you have to check, hey, go through that 5-letter word and make sure that, you know, each letter in each position is in a match or not. That's a really good case for a for loop because you know it only needs to run 5 times. You could also replace, you know, this range argument with like some variable from the console, right? Maybe they type in like how many guesses they get, and you're going to run the for loop that many times. But for loop is good for, you know how many times you want it to run. A while loop is just going to run who knows how many times until this condition becomes false. So if you don't know how many times you need that loop to run, like on your Wordle lab, you ask the user to type in a guess. If that guess is not valid because it's not a proper word or it's not exactly 5 characters long, you need to not penalize them. You can't deduct their guess count and start, you know, ask them for another input. You need to just throw away the invalid input they gave you and again just ask for a valid input. If you do that with an if statement, that'll only happen 1 time. If you do that with a for loop, you have a limited number of times before they run out of attempts to put in a valid input. That is a good condition for a while loop. You don't know how many times they're going to fat finger a key or just try to troll your program by typing in invalid inputs into your Wordle. You need to have a while loop that just says, as long as their current guess is invalid, print a complaint, tell them the instructions again, and then ask for a new input. And then make sure whatever variable you are using to hold their guess and that you are checking against your validity, whatever your true false, like is the guess invalid? And if it's invalid, print the complaint and prompt them for a new one. Whenever you get a new one, whenever you get a new input from them, you need to overwrite that existing variable that is in your while loop's header, kind of like how we do here. We overwrite this value because it already exists and we assign it a new value. You need to overwrite their guess value with whatever they type in until they type in something valid, and then the while loop header will become false and the rest of your program can keep running. Those are like the main when to use one kind of loop versus another. You can, if you're clever enough, you can use either loop to do pretty much either thing. Like I could have this iterator value in a for loop that only runs like a certain number of times. Or I could define my for loop to be like run this variable until, you know, it exceeds some value here. Like if this was a variable, I could be a prick and manually tick this up inside of my for loop. And now I'm pretty sure that for loop is going to run forever. I need to define this variable first because I'm using it here. Let's start it at 5. Interesting. Okay, disregard that. You can find a way, a creative way to write a for loop that'll run forever. But don't do that. When you use a while loop, either your loop condition can become false as the loop runs, because you overwrite the variable that determines whether or not that loop condition is true or false. Or you've probably seen some people just write a straight up infinite loop. While true, do some stuff. This is going to run forever because this is not a variable. You can't change this value. This loop will keep resetting, and this loop condition will always be true. So this loop will run forever unless you manually break it. So whenever you use a while loop, you either have to manually break it or manually change the condition, the variable that determines whether or not the loop condition is true or false. That is the important thing to remember with while loops. They're very flexible, they're very open-ended, but the similarities between for and while loops, there's a lot of them, but those are the two things to remember. The for loop will automatically tick up the iterator for you, and the iterator is provided. The while loop, you need to declare your iterator, if you're going to use one, and then manually tick it up. And you either have to manually do something to change the truth value of the while loop's condition, or manually break it. While loops are very manual, for loops are very automated. For loops are good for a fixed number or a known number of runs. While loops are good for just keep running until it's right. Okay, over and out.